So the next effect we're going to create for this is the burnout effect. So just as we did with the burn effect, we're going to have a new custom value set. We're going to call this fuel, and we're going to have this decrease once the particles reach a value of 1. So to do that, we're going to make a new get and set node. So we get a get data, a set data. And actually, before we go ahead and do it in the simulated tree, we should do this in the initialize it. So we're just going to go here and go to the initial tree. We're just going to copy this entire tree, Control C, select all those, Control C, Control V. We'll link this into the ice tree, and we're just going to change this from, at the moment it's called burn. We're going to change it from burn to fuel. So we'll set the data first. And this is a new attribute that fuel doesn't exist yet until I hit enter and close this down. If we explore, there's no fuel. Oh, it is. Well, if we create it now, so it's in there. But once it's created, you have it. And again, we change this to fuel, explore, and fuel. Okay, so we have our fuel set. We're going to set the fuel to a value of 1 to start with. We want to start at a value of 1. So we're going to add an add node. Just put it between these two here. And just add a value of 1. This is a not simulated ice tree. If you put it under the simulation, it would increase that value by every frame, and that would be a bad thing. So that's why it's under the initialized ice tree. So let's go back now to our simulated ice tree, and next thing is to actually have this value decrease. So we've got our get and set data. So we're going to go in here, and let me just get rid of this node for a moment because we're not going to use it for a second. Just move it out of the way. And we want to set the fuel. So we'll just go here, self, oops, get capitals, self dot, and we can explore it if we want, or just type it in. You see the fuel is on there now. And we're going to get the fuel as well. Often you always start with getting and setting data, and then of course changing it by a certain value. We want to reduce this by a certain amount. So let's go in, and to reduce it we're going to need a subtract, and we'll just link these in. Now it's when do we want to subtract it? Well, we want to subtract it when this value is at 1. So we need an if to get a condition to decide when we're going to subtract it. And then it's going to be if it's greater than or equal to 1, or just equal as well would work, but let's say greater than or equal to, and that's going to be our condition. We can get that data from this clamp node here, or straight from here as well. So we'll just bring it into the first, and then we know that this is taking our current burn data, and now we're just saying the burn data if it's, you know, greater than, we just set this to 1 or equal to 1. We're going to start decreasing it by a certain step, and we'll decrease it by 0.1 per frame. So let me feed this in to the true. And again, if it's false, well, we'll just keep it at its current value. So we'll just take the get fuel and just leave it in another set data. So we can rearrange this slightly so we don't need two set data. So that's what I'm going to do now. Just going to rearrange this very slightly by moving the set data in here. Just going to make the graph a little cleaner and require less nodes. It's always a good thing. And there we are. So if it's true, we're going to subtract. If it's not true, we won't subtract. So quite a lot of different nodes here. But really, let me just again move these down so we can kind of tell what part of the graph is what, because we've got some, connected graphs here, but we can break them apart separately if we need to. So what we're doing here is we're just doing a get data of the fuel. We're subtracting it if the value is greater than 1. We're doing this per frame. We're going to lead this into, connect this into our ice tree. Oops, wrong node. Let's do this again. Hook that one there. And hook this one into port 3. And the node I had before, this get and set, I'm just going to change these as well, just so I can preview it. So let me just, same idea as we did before. Just going to put this at the end of our ice tree, just for a quick way of testing, see what's happening at the very end with these values. Show values, numeric. Just hit play, and we actually see the numbers are decreasing, and it's working, except it's going down maybe a little bit too low. Just as before we had the clamp node, we'll do another clamp node to make sure the value doesn't go below 0. In the value in here, in the fuel, and just clamp it between 0 and 1. And now we have our fuel that decreases to 0 over time, and we can make that decrease step slower by just adjusting the subtract. So we could say, subtract 0.05, and that will make it burn for longer. Great. So our fuel is decreasing, and now if we go to the final step of this is make sure this works for our particles. So right now the fuel decreases, but they stay burning. And the reason we put this on the new node fuel instead of on the burn is we want to be able to have an area that's burnt out and then not reburn. So we pick the particle cloud again, and it's almost identical to this, but we're going to be doing a fuel instead of burn. So I'm just going to move some of the ice tree around a bit here, just organize so I've got a bit more space to work. Take this whole tree by middle clicking the branch, Control C, Control V. Hook this one in to a new execute on emit, and instead of burn, we're going to get fuel. We know that in this case, you can see right now, if I just hook it in, the fuel is 1, as long as it's 1, but once it goes 0, it's burnt out. So that's working quite well. I need to tweak it a bit, because right now this is set to 0.5. I'm going to set this to 0.1, just so it burns a little longer. And we'll turn off the node so you can actually see everything a little clearer, and then we'll just tweak some nodes until we get the result we want. So maybe even less, 0.05. And I'm just going to go back to the object ice tree, refresh that, and just turn off this visualization so we can see what's going on. Hit play and watch what's happening, and you can see there it goes, and it's burning out quite well. It's probably not spreading fast enough, or it's burning out too fast. So again, this just subtract step is really one we want to have pretty low, this number, to control how quickly the particles do burn out. And 0.01 may be too little. They are burning out, but they're burning out pretty slowly. So we'll go up a little bit higher, maybe 0.025. And I think that should be pretty good. Again, you can tweak these numbers and work with things. And yeah, that's looking pretty good. It looks like it's burning roughly how I'd like it to burn. If I want to do more, I can. But it's burning out pretty fast. Again, we can tweak these numbers as much as you like, and you can spend a lot of time tweaking and playing with these numbers until we get the look right. Remember, you can work the number in here. We can also work the number on the particles themselves. So we can see here, at the moment at 0.05, it's when they will no longer go. We can say when it's less than 0, or less than or equal to 0. Then they'll stop burning, just to give it a little bit longer, because of course once the fuel is completely depleted, then you can actually have them burn out. You can also tie that fuel rate to the particle rate, and lots of other things actually have less particles emit where the fuel is lower, kind of burning it out instead of just stopping. But it's pretty nice how it looks right now, and I'm happy with how things are going. So that's our fuel attribute, and we now have particles that ignite and burn out, last for a certain amount of time, and everything's going pretty well. There's a few more steps to do this to make sure. Next thing we're going to do is make sure that the particles can ignite themselves. So if there's flames on a part of the stick, instead of just spreading as it does right now, we also want the particles to actually reignite areas. So if the flame touches an area, it's going to burn faster or slower depending on where the flame or direction of the flame is.